So here we go. Here's a problem to solve. Oh, I know. We're going to integrate that thing.
Hmm. So problem is that we've got a division.
Camera died there. We've got a division, yeah, which we don't like. Yeah, I don't like divisions and integrals, that's for sure. Or in general.
Right.
Mhm.
So we need to somehow separate it into like parts.
Well, quick question. What kind of function is it?
That is I think that's a not a I think that's just a standard function.
Standard.
It's not a composite.
How would you define a standard function?
I can't.
Okay. Good, because I never mentioned it before. Where's that come from? Yeah, not a composite. Okay, why wouldn't it be a composite?
Um, well, there's only one function there. There isn't two.
Yeah, so there's a straight line, 3x minus 2. Yeah, that's the function itself, straight line equation. Y equals 3x minus 2, gradient 3, cut minus 2. But something's happening to that, isn't it? Which has been square rooted.
Yeah.
So something's happening to it. So it's in a bracket, like we just did with the binomial. The
Yeah.
bracket for power 1/2, isn't it?
Mm.
So that makes it a composite because it's literally in a bracket. It's in our Russian doll shape thing. I always think of Russian doll looking at, like there's brackets. It's a Russian doll. So if something's in a bracket to some power, that's a composite
Right.
because it's inside. We can't. If I times it by 5, it won't do anything to the thing inside it. Just times by 5. That's normally a good test whether or not it's a composite or not.
Okay.
If you times a thing by something and nothing happens to the thing inside it, because it's inside the Russian doll. So if you paint the Russian doll a different color, the thing inside stays the same.
Yeah. Yeah.
Yeah, it's a bit like that. Very, very loosely like that, but that's kind of what's going on.
Okay.
So, we would want to write. It's a lot of W's. We would want to write the 3x minus 2 in a bracket. And to what power would it be?
1/2 half.
Exactly, yeah. Okay, so we can do that to start off with. So let me write that down, and then I'll just switch the screens. So 1 and 2, 1, 3x minus 2 to the half dx. Which you should be able to see.
Yeah.
Okay. Now, what can we do next? What should we do next? What can we do next?
We want to try and get rid of the division somehow.
Yes. It's exciting. Yeah, what's the easiest way to get rid of that division?
You can times it by the bracket. What's in the bracket?
What's the simplest way of getting rid of that division?
No, just flip it.
Yes. And what
So it's if you the whole fraction to the power of -1,
yes.
which would flip it.
It would, yeah. What would be the effect on what would it look like after that?
It would be 3x minus 2 to the power of 1/2.
But that's not the same thing, is it? Because at the moment it's 1 divided by that. So if you just go, oh well, let's call it the same thing but on top, it's not the same thing. We need to acknowledge that's happened to it.
Yeah. I'm not too sure.
Well, you're right in what you said, but you need to acknowledge what you did to it, that's all. So what you sort of said was, I think, I'm just going to take the reciprocal of that.
Yeah.
So that means putting it to what power?
-1.
Okay. What do brackets mean?
Multiply.
Right. So 1 to -1 is 1. That won't do anything. And that makes 3x minus 2 to -1/2. Yeah, because -1 times by 1/2 is -1/2.
Yeah.
And how is so that's it really, just write it like that. So that acknowledges that that's what's happened to it. So we just write it by -1/2.
Yeah.
Okay, so that brings it up. Yeah. The negative power brings that thing up.
Yeah.
Yeah, above it. The reciprocal. Negative is reciprocal. Yeah. So we want the reciprocal with a negative power. Okay, so now what?
So now we've got, this is still a composite function
Yeah, brackets.
because we've got,
Yeah.
so now we want to try and do something with the power, kind of like separate it.
Yeah. Well, we're looking. The topic we're looking at today is integration by substitution. So we're going to substitute something. So
Right.
what do we substitute and what with?
Well, we want to try and substitute what's in the bracket.
Yeah, with
U.
u, exactly. So we just set, normally we say let u equals 3x minus 2. Okay, so that changes the integral to u to the minus.
Right. Yeah.
Which is a lot easier to integrate. But there's a problem. We can't just go and integrate that. What else do we need to change?
The power.
No, that actually stays the same. Everything
Right.
changes, but that stays the same.
So we have to write the integral out again, but put U in the place of.
Yeah, we can do, but I could do, but it wouldn't really be correct to do that. It'd be okay, but it wouldn't be actionable.
Right. Okay.
Incorrect. We need to change everything that needs to be changed and then write it afresh, rather than change it piecemeal. So the power will stay as it is, and that will make it, as you said, use the -1/2. So that won't change. But what about the dx?
Oh, du becomes du.
Yeah, we need a du there, because now we're going to integrate with u as the function, not x. So
Yeah.
we need to times it by du, because the whole idea of integration is you go along a bit, what's the change in that
Yeah.
bit? Yeah. But if it's x and the thing is u, it doesn't make sense.
No.
It has to be the change has to be a bit of the thing that is changing. So the whole idea of integration is sums all the changes up. So it's a little bit of u. So we need to find du. So how are we going to find du?
Du is the derivative of u.
Yeah. So we differentiate. If we differentiate, that generates a du. And that gives 3. So to substitute du in there, we notice that dx is du divided by 3.
Yeah.
So I can get rid of the dx now and replace it with du divided by 3. So now the whole thing's in terms of u, because it's going to be u to the power minus 1/2 du divided by 3, which is fine. Okay, does that all make sense?
Yeah.
Yeah. Anything else we need to change? You're thinking no, but it must be because he's asking me.
Don't think so.
Everything changes except for the power, even the limits. Because the limits
Right.
1, 2 are in terms of x as well, because the function is in terms of x. You know, the function is on a graph, which has got x on the bottom, and the limits, they want the area between 1 and 2. But we've changed the whole thing to u. Okay. So that this goes out the window now, and those numbers wouldn't be correct. So you've got to change the 1 and 2 as well. And the way we do that is we use the equation here. So you just do, for 2, u will be 3 times 2, x is 2, minus 2, 4.
Yeah.
And for 1, 3 times 1, minus 2, which is 1. So it stays the same, fun enough.
Yeah.
The new integral will be 1 to 4, because they're the new limits in this new world of u.
Yeah.
U to the minus 1/2, because we changed 3x minus 2 to u. Du over 3, because we changed the x to du.
Yeah.
So now it's all completely changed in terms of u. The limits have changed, the function's changed, the little bit of x has changed to a little bit of u.
Okay.
So we just got to evaluate that now. That is a lot simpler than, believe it or not, than
Yeah, it is.
because how would that integrate?
It would be you add 2 to the power.
Add what to power?
2. Oh no, 1. Sorry, you add 1 to the power. So that would be 1/2.
Right.
Then you divide the coefficient of u by that. So it's like 1 divided by 1/2.
Yeah.
Just the half. So it should be u over 2.
1 divided by 1/2 is not 2. It's not 1/2. No. 1 divided by 1/2 is.
Oh, sorry. Yeah. So it'd be 2u over 2, which would just be u to the power of 1/2.
Fractions are a pain, aren't they? So first thing we can do is this 3 here. This is a bit odd that it's kind of lingering out here. It's okay, but it's a bit odd. What we're now doing is just shove it outside. You don't have to, but we're allowed to do that. So I've just put it outside, get out of the way. Because all it's doing is dividing the answer by 3. So that's the same thing as multiplying by a third.
Yeah.
So I'll just shove it out there. And then u to the half minus 1/2. Yeah, as you said, I need to add 1 to it. So it's going to be u to the power 1/2. And oops, a bit too fast there. And then divide by 1/2. So divide by 1/2. How many times is 1 going? How many times is 1/2 going to 1? How many halves are in 1?
2.
2. Yeah, so times by 2. So that's it. So 2u to the half divided by the 3. So all 2/3 times u to the half, which is the same thing.
Yeah.
Okay, any questions so far?
No.
No? Okay, so we'll just recap that, okay, because there's a few steps to it. So this is the original problem. You said, I don't want that division. First thing you said, get rid of the division. So put it up there. So power minus 1/2. Replace the 3x minus 2 with u. And then generally replace everything with u. So dx needs to become du. 1 and 2 needs to become in terms of u, not x. So differentiate to achieve that. Substitute for dx. Use the substitution to figure out what 1 and 2 will become when it becomes 1 and 4. they become 1 and 4. And then we have our integral in terms of u. Yeah. And then I've just taken the third out and then actually to evaluate it. So increase by 1 divided by new power. So the answer is 2/3 e to the 1/2.
Yeah.
Between the limits 1 and 4. And then we just put 1 and 4 in, or 4 and 1 in. So I put 4 in. The 2/3 could just sit there doing nothing for now. And we just put u to the, so 4 to the half, that's 2. Because it's the square root of 4. Yeah.
Yeah.
Take away 1 to the half, that's just 1. So after all that, the answer is 2/3.
Right.
That's it. We did it. First. Any questions?
No.
No. The first step is to notice that it's crucial that you won't be told, you see. It's crucial that you recognize that it's a composite function.
Right.
The first thing you said is it's not a composite function. Right. But if you don't know it's composite, you won't know to integrate by substitution, because that's how we integrate composites.
Yeah. Yeah.
Really, this is just the reverse of the chain rule, which is what I call it differentiation by substitution. It's where we differentiate a composite function. But what if we want to integrate one? Well, same thing, let u equal that. And do it in effectively sort of do it in reverse. Change it all into u and evaluate it.
Okay.
How could you check the answer was correct?
Well, you could, because it's an integral, you could differentiate it.
Yeah, but because we actually found a specific value for the area between 1 and 2.
Yeah.
Maybe we could use this guy.
Hmm.
Just check it on a calculator. Yeah.
Right.
Give you a number, won't it? So let's have a look. Do you want to type it in or should I get it? Okay.
Just trying to find the actual integral.
Sorry, yeah. So it's the integral of 1 over 3x minus 2 to the power 1/2 between the limits 1 and 2.
So 2 then sorry.
Okay.
Uh 1 over yeah, 2 over 3.
2 over 3. Yeah, exactly. So we can, that's good. So yeah, so if we're in the exam and you've got time, just want to double check it's correct. Just whack it in the calculator, see if it actually does agree with your working. Because if you made a mistake somewhere, you can find out, oh,
Yeah.
not what I thought. Why is that? I wouldn't run. And then you might spot something.
Yeah.
Okay. Any questions on that?
No.
No, do you think you could do that?
Yeah, maybe. I get it. I get like the logic of it.
You get the logic of it? Okay.
Yeah.
Yeah. I think it's okay. If you get the logic of it, that's the whole idea. That's what we're trying to accomplish. Yeah.
Yeah.
Okay. So let me get the second example. That one, no, that one. Yeah. Yeah, perfect. These are from exam papers, by the way, so past exam papers. So these are kind of the authentic questions.
Jesus.
That's not my name, no. So yeah, show that the substitution U is so there you go, it's telling you to use substitution there.
Right.
It even helps you out by forming the integral for you, or it tries to. So notice quite a similar thing, you've got a du there, you got u to the power stuff, and in front of it you've got a fraction.
Yeah.
So it's quite similar to the previous one, and they often are similar in that respect.
What happens to x though on the top of the fraction?
Well, that's what we're going to look at now. Wow.
Right.
It's a good question. Yeah. We'll see, won't we? So let me write that problem down. So the problem is the cube root of, sorry, x divided by the cube root of 2x minus 1 dx. And we're going to use, obviously, u equals 2x minus 1 is our substitution. And we're hoping it's going to become that thing at the end of it.
Right.
It says, hence find the exact area of the region between these points. So in other words, integrate between these limits. Okay. So I'll come back to that. Let's just get the show that bit done to see if it transforms. So let's go to my whiteboard. There we go. So the first thing is we want to change this thing in the brackets there to not in the brackets. Well, it's not in the brackets, the brackets. So we could express it as x over 2x minus 1 to the 1/3 dx. We're going to let u equal 2x minus 1. So what's our next step?
Well, we need to put, so it would be the integral of x over u to the power of the third. And then we'd need to change dx to du.
Yep. So how are we going to get du? We're going to.
So we say du over dx is equal to 2.
Very good. Yeah. So du by dx is 2.
So du is equal to, no, dx, sorry, is equal to 2 over dx. There's dx over 2, sorry.
Say that again.
Dx so du is equal to no, sorry, dx is equal to du over 2.
Du over 2. Okay. So we're gonna, so as before, we'll put those in. We don't need to do the limits at the moment because there aren't any.
Yeah.
So we'll just put those in. Okay, and I'm sure everything will be fine. So x, oh, there's a problem straight away. U to the power 1/3 du over 2. What seems to be the problem here?
Well, we've got an x and
exactly. Yeah. So as you identified, how are we going to get rid of this x? Okay. So there now we just do a bit of algebraic trickery. Because remember before, we said that we let ux. I shouldn't have had that. Sorry, I shouldn't have had that kind of Red Bull. I didn't think it would. I was tired and I thought, oh yeah. Not like never again. Okay, so we let u equals 2x minus 1, right? That's what we said it was. Okay.
Yeah. So we need to rearrange for x.
Exactly. Thank you. Yeah. Do my thinking for me. Thank you. Yeah, so just make a subject, and then we'll have something in terms of u, won't we? So we can just replace the x with that.
Yeah.
So you have 2x is equal to u minus 1.
X should be x, yeah, divided by 2.
Right, so
right.
Put that in there, right? Because
then
this is not really what we want because it's a mixture of stuff.
Yeah.
Yeah, go on. I think you're going to raise another objection.
Yeah, it's like divided by
Yeah, it's like a world of horrible
x.
prison. Yeah.
Yeah.
So what's all that going to equal? Well, all that means is u minus 1 divided by 2 divided by u to the power 1/3 is just u minus 1.
How is that?
It's because
Wouldn't
of
it be?
fractional.
Sorry.
Yeah, so if you divide a quarter by 2, a quarter divided by, can't see it. Do a quarter divided by 2,
It's a quarter times 2/1. So it'd be 2/4, which is a half.
No, it's not times 2/1, is it? So a quarter
Right.
divided by 2 is a quarter times by a half. You use the reciprocal, and that's 1/8, which is the same as just timesing the two together.
Right.
Add
Yeah.
u minus 1 divided by 2 divided by u in a third. It's the same as just doing 2 u to the 1/3.
Yeah.
Or 1/4 divided by 2 is 1/8, isn't it? If you've got a quarter of a circle and you divide it by 2, it's 1/8 of a circle.
Right.
So u minus 1 divided by 2 divided by u to the third is the same as just timesing those two together. And then times that by du over 2 is 2 2's there.
Right.
I've never done maths on a kind of red ball before. I don't think I'll ever do it again. Then we get a 4 there. So I can just change that for a 4.
Okay.
But okay, because it's over 2 times by du over 2. So 2 2's are 4.
Yeah.
Yeah, is that okay? Sure?
Yeah. No, I get that now.
Yeah. Okay, so that's all horrible stuff. Yeah. All horrible. Yeah, all horrible. But what we could do with that 4 is remember we could take it outside because it's not doing anything. So 1/4 integral of u minus 1 divided by u to the power 1/3 du. Next up, got a division. Don't like divisions. So we'll actually just divide. So what's u divided by u to the power 1/3?
It's like the cube. Is it the cube root of u? U over the cube root of u.
That's what it is, yeah. What does it equal?
Um,
Division. What's division?
Subtraction.
Okay, so subtract the powers.
So 1 minus a third.
Yep.
2/3.
A third. So use the 2/3.
Right.
Minus 1
1
divided
over
by u to the third. So that'll become
minus 1 over a third.
minus
Sorry. Yeah, u minus a third.
u minus a third. Yeah. So let me do a different color for that. So it's that divided by that. So u minus 1/3.
Yeah. Which you can
du. All right.
yeah.
Okay. So let's see if that agrees with what we saw before. There we go. So 1/4 use the 2/3 plus use the minus 1/3 du. It's the same.
Yeah.
Simple. Not really.
Mm,
You're paying. But that's as hard as it'll ever get for integral
okay.
substitution because you've got to do a few tricks. So first thing is you've got to substitute it. No, let me go through it on the screen and that sort of thing.
Yeah.
But it tells you to substitute it, so that's helpful. So it says replace it by 2x minus 1. Okay, I'll do that. Differentiate it. That gives us du over 2 for dx. Still got a problem because we've got an x. So we just do a bit of, that's the extra bit. That's the hardest I'll ever get. I've just got to do a bit of rearrangement. But it's good that you noticed the x. You know, what do I do about the x then? Well, now you know. You'll think to yourself, you see that again. That's a problem. How am I going to get around it? Use the substitution.
Yeah.
What integration by substitution? Yeah. So replace that. A bit of nasty division stuff, but we're going to end up with the very final expression of u to 2/3 minus u to 1/3 times a quarter, and then you'd integrate that. So usual way, increase the power by 1, divide by new power, and that's your answer.
Great. Okay.
So the problem itself asked you to integrate between the limits 1 to 1 to 4.5. What would you do about those?
Um,
Do you have to do anything with them?
so those are the limits, they.
Yeah, so remember it said find the area of this between, oh, maybe you don't remember. Let me show you.
Yeah. So one would be, it's 1 to so the top part it would be like the integral, and then 1 at the top, and then 4.5 at the bottom.
No, show the way actually. 4.5 at the top.
Oh right. Yeah.
Yeah. Because we integrate the big thing and take away the small thing. That leaves
Yeah.
it in the middle.
Yeah.
So 4.5 evaluated and then take away the one value. But notice it's x equals 1 and x equals 4.5. Isn't that going to be a problem considering our integral is not in terms of x?
So we'll have to substitute x back in.
Right, exactly.
Okay.
So we use
U.
no,
So
we don't
basically,
put x back into the integral. No, we've got the integral
no,
now.
we need to substitute 2x plus 1 for u.
No, we've done all the substitution and we're done. That's all the point of it. Now
Oh
we
right.
yeah. So now what we need to do is rescale the limits because they're in terms of x. So u
Okay.
is 2x minus 1, yeah?
Right. So so it's, if x is 1, it would be 2 minus 1, so 1.
Right?
And then if x was 4.5, it would be 2 times 4.5, which is 9. 10, yeah, 9. And then minus 1 would be 8.
Yeah, exactly. Sorry, I'm ashamed. You can't see what I'm writing.
So it should be 8 and 1.
Yeah, so we're going to integrate from 1 to 8, exactly. So we
Okay.
integrate it usual way.
Yeah.
Increase 1 by power, divided by new power, etc.
Yeah.
Evaluate it from 8 to 1. Whenever we get times by a quarter, break open the champagne. Integrated it. Yeah, but it's something that you need to do about 10 of to get fast at.
Yeah.
And once you do, you will. It's always the same process, really. It's just that changing. Just it's kind of like a transform. It's in x. Make it in terms of u, then do it.
Yeah. Yeah.
Either in those two examples, we've got actual values for the integral. If there was no limits on it, you would return the u's back. Then you'd return the u's back to x, so that you get an answer in terms of x.
Right.
And that's it. Cool. Okay.
Okay, cool.
Any questions on any of that?
No, I need to practice that definitely.